What do we know about detectors in cytometry? PMTs have been used for decades. PMTs are fast, sensitive and clean. Virtually all flow cytometers use PMTs. So what would a cytometer look like with no PMTs? None. Zip. Nada. No PMTs. Well, there are no PMTs in the Cytoflex because it has APDs instead. So what's an APD anyway? It's an avalanche photodiode. Well, what's the difference between a PMT and an APD? Well, APDs are funny little things that look a bit like tin cans with a window on the top, whereas PMTs are, well, not so small. So why change to APDs when everyone else is using PMTs? A major advantage of APDs is the high dynamic range around 1 million, compared with about 10,000 for a PMT. Another advantage in an APD is this huge gain is almost perfectly linear. Did I say that they're 10 times cheaper than PMTs? Another big difference between an APD and a PMT is the bias voltage. You remember that PMTs typically require around 1,000 volts, whereas APDs are about 20 to 90 volts, and it's not continuous like the high voltage has to be on a PMT. The big deal for the latest APDs is their amazing quantum efficiency, near 90% compared to maybe 20% for a PMT. So remind me what an APD is again. Basically, APDs are silicon photodiodes with an internal gain mechanism. Absorption of incident photons creates electron-hole pairs. A strong internal electric field is created by a high reverse bias voltage. This field accelerates the electrons through the silicon crystal lattice to produce secondary electrons by impact ionization, and the resulting electron avalanche produces a high gain. So if you think of what happens in a real avalanche, where a small ball of snow builds up to a powerful event, you get the gist of what is happening in the APD. The big deal about APDs is their incredible quantum efficiency. Remember what QE is. It's the number of electrons emitted divided by the number of incident photons. So efficiency is important. Even more important is the wavelength range that the APDs can handle. This can be low, like 200 to 400 nanometers, or high up in the red at 600 to 1000 nanometers. So the bottom line is that an APD can be used in a flow cytometer after all. Properly designed, APDs can provide the same quality results as PMTs. It's one of the reasons the Cytoflex is so compact, but high quality. One mean APD machine.